Force is a fundamental concept in physics. We experience forces every day, at every moment, and in everything we do. Without force, we could not walk, talk, or breathe. But what is force? We've already introduced one type of force, called gravitational force, which causes two masses to be drawn towards each other. In fact, a force is an interaction between two objects. When such interactions occur, the force causes the objects to change their state, usually resulting in acceleration or change in motion. A force only exists if there is an interaction between the two objects. In this video, we will look at the concept of force and introduce the first of Newton's three laws of motion. The concept of force has been philosophized for centuries. Physical forces were first described by Archimedes 200 years before Christ. But it was not until the 17th century when Italian physicist Galileo Galilei made inroads into the understanding of forces when he questioned what made objects move. He formulated the notion of inertia, which is a state of motion which causes a moving object to keep on moving if there are no other forces acting on it, or for an object to remain stationary until a force acts on it. This idea was further extended a few decades later by another physicist named Isaac Newton. Newton built on Galileo's concept of inertia to say that inertia is the object's tendency to resist change in its current state. The inertia depends on the object's mass. Newton states that every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. This became known as Newton's first law of motion. In recognition of Galileo's contributions, this law is also known as the law of inertia. So let's have a look at some examples of the first law. Consider sitting in your car at a red light. The light turns green and you begin to accelerate. In that instant of acceleration, your head is pushed backwards. This is because of your body's tendency to remain in its initial state of rest and its inertia resisting the forward motion of the acceleration. The same is true when the car suddenly brakes and you are lunged forward, or turns swiftly, throwing you to the side. This is because of your body's tendency to stay in the moving motion prior to the braking or the turning. Now let's see if you can apply Newton's first law to answer this question correctly before moving to the next video. A hockey puck is sliding easterly on a frictionless horizontal ice surface in a straight line from point 1 to point 2. At point 2, it is swiftly struck by a hockey stick in a northerly direction. Which of the following paths would the puck most likely follow after the strike?